finish off this sheet, we're going to have a look at question 10. Question 10 is quite a famous proof in inverted commas. There's a very big mistake in this proof, and this proof apparently leads to the result that 2 is equal to 1. Now, as mathematicians, we should be very unhappy with any proof that gives us 2 equals 1. We know this result isn't true, so one of these steps somewhere up here must actually not be true. So, we're given this at the start. For any two equal numbers a and b, a equals b. So we need to start having a look at these. So a equals b. Is this true? We're given in the question that two equal numbers a and b. True as a and b equal. So we're happy with that step. The next step, we've got a squared equals ab. So what has been done here, we've multiplied by a. Because this has gone a to a squared, this has gone b to ab, we've multiplied through by a. Are we always allowed to do this? A is any number. Can we multiply by any number we like? Same on both sides? Yes, we can. We can always multiply through that. The next step, what have we done? So we've got a squared minus b squared equals ab minus b squared. So here we have subtracted b squared. B squared is a number. If you were given the value of b, say the value of b is 5, can we subtract 5 squared from both sides of an equation? Yep. So far, if we pick two numbers that are the same, we can multiply it by a and we can subtract b squared, and the numbers are exactly the same. What's next? We've done some factorising. A plus b, a minus b, b, a minus b. Now what we've got here are some factorising laws of algebra. We can always do that and we can always do this. So these are algebra laws, and these are always true. So the next step, we have jumped to a plus b equals b. So what we've done here is we've divided both sides by a minus b. So this is essentially cancelled out a minus b here and a minus b here using division. Now we should be thinking to ourselves, can we always divide by any number? Some of you might have spotted this or not, but there is one number that we're not allowed to divide by, and that is 0. Can't divide by 0. Maybe that has something to do with our proof. So this a minus b. Well, if a is the same as b, then this is the same as a minus a, which equals 0. So this bit here as a equals b. So this is actually 0 every single time. So what we're doing here in effect is dividing both sides of this equation here by 0, and we're not allowed to do that. So this is our problem here. So this is our reasoning for why it doesn't work. This step here involves dividing by 0, so this is the step that doesn't work. There's no point checking any of the rest of the proof. If you've got one error in a proof, everything else you do from then on is incorrect. So the correct answer for this is it breaks down at this step here, which is the division or cancelling step, because we can't divide a number by 0. If you know enough algebra tricks, if you know enough factorising tricks, you can actually use this proof to say that any number equals 1, so you could prove if you wanted to that 15 equals 1. So it's quite a nice little mathematical trick to play on people who don't realise what you're doing, and it's all about this dividing by 0.